Right, this is just part one of going over some stuff from chapter four. Remember, chapter four had a lot of vocabulary in it. Um, you might want to consider looking back through first semester note stuff if you kept it. There was a crossword puzzle that had all of the terms and definitions on that as well. I don't know if that would be something you might want to dig up and look over again because that seemed to be helpful. Um, this would also be um, something that you might want to consider looking in your book for definitions and things like that, just because of the amount of vocabulary. I also know that there are Quizlets made already. If you literally search AP Stats Chapter 4, you're gonna find Quizlets already made on all of this vocabulary. So just some options. Um, all we're going to talk about in this video is sampling, and then I'll have a separate video for experimental design. I would imagine on the AP test, they would probably lead you at the beginning of a problem with something about this topic, and then maybe take it further into inference, like panic and phantoms. So I think there's a good chance you will see this on the AP test. So anyway, let's just kind of do a quick run through. There's lots of different ways to take a sample. Some ways are good and others are not so good. So let's start with the not so great ways. So voluntary response sample, that is one of the easiest possible ways to gather a sample. You just go up to people who are easy to find, and ask, well, I shouldn't say easy to find, that's kind of more convenience. With voluntary response sample, it is easy, but it's like just sending an email out, like an email survey type thing. Or it might be a flyer that you have to mail back in your response. Or back in the day, they would, like on TV, they would flash a phone number that you could call. So it's when you're invited to respond, but you don't have to. And only the people who respond are counted as the sample. So the sample is not the number of people you emailed, okay? It's the number of people who responded. That's too big. Oh, there, my pen is being weird. So the sample is not the number of people you emailed. It's the number who responded. So, you could say to yourself, oh, okay, I want a sample of 100. I'm going to send out 100 surveys, but let's say only 10 come back. 10 is your sample, and that's not great. So you would have to probably send out like 500 surveys in order to get even a big enough sample. But even then, it's not going to be a good sample. It's not random. People who take the time to fill out a voluntary response sample probably have strong opinions. These are the people who are just all fired up and they want to be heard, and so they're going to send back their opinion. And usually the strong opinions are negative. Yeah, I think that's pretty much it on voluntary response. Convenience sampling, that's just like going up to whoever is close by and just asking them to be a part of your sample. It's also not random at all. There's most definitely going to be bias involved. And at the time you're doing it, you might not realize what the bias might be, but it definitely comes into play. And you should always, always, always do the best you can to eliminate unsuspecting bias. Because you can't fix it after the fact. So you need to have random samples to help avoid that bias. Next are the good sampling techniques. So a simple random sample, it's abbreviated SRS. They would use SRS on the AP test as well. This is what we used to refer to as the hat method. I don't want you to refer to it as the hat method on the AP test. So don't say that on the AP test. So what I'm saying is don't refer to simple random sample as, quote, hat method, okay? Call it an SRS. But an easy way to describe it is to use the hat method, meaning you number all of your subjects, or not subjects, I don't know, number all the people, 1 through whatever, on identical slips of paper. Put into a hat and mix thoroughly. And then you're going to draw one out at a time. Until you get your amount that you want. And then those numbers correspond to the people that are going to be in your sample. Now, it doesn't always have to be people, could be dogs, whatever it might be. But make sure that you tie back the fact that those numbers represent something. Okay. The next one is stratified random sample. Now be careful because that does abbreviate to SRS, just like simple random sample does, but we only call simple random samples SRSs. So stratified and cluster, these are the two that you guys would get confused a lot. So in stratified, you're going to divide your population into groups of similar units. And then you're going to take an SRS from each of those stratum. So you would have maybe males, let's say, in one group, and females in another group. And then you would take a simple random sample from each of those. So this group has similar units. This group has similar units. It's like I have two different hats. And then I'm going to select a simple random sample. So maybe I will pull out 20 names or 20 numbers out of the females and 20 out of the males. So stratifying is good because you're going to have equal representation from each group. Okay, cluster is when you separate into groups, except now your groups are mini populations. So like back up in this strata, this is males, that's not a mini population, because it should, if it was a mini population, it would have a mix of males and females. This is only males. Cluster, I would have a group, and in this group there would be a little bit of everything. Maybe I'll do, like, I'll use colors to represent a little bit of everything. Okay, I don't know, whatever. All right, so think of it, I don't know, think of it like a cookie with sprinkles. How about, You got all different color sprinkles. So you would have several of these groups that have many populations, and then you are going to choose. I wonder if I can copy this faster. Maybe? Oh. Well. Okay. See if that works. Probably not with my luck right now. All right, well, okay, there we go. So now we've got 3 clusters, mini populations. I would number those clusters, like maybe this is cluster, and I need my pen. Maybe this is cluster number 1, cluster number 2, cluster number 3. I would put those numbers in a hat. And maybe I would only draw out one number. And then let's say that the number I draw out is number 2, let's say. Oh, that picture is kind of misleading now. It looks like 2 groups. Okay, so here's my hat. I'm drawing out one thing. And let's say that that one thing is the number 2. Then that means that I'm going to use this entire group. Everything in the group is chosen as my sample. Now, you don't have to just draw out one thing. If I have like 20 groups, I might draw out 3 to 5 of them or something. And then I would use everything in all of those clusters that were chosen. But everybody comes along with this. Here up in Stratified, you're only selecting a few from each group. Okay, so this is this general idea that in Stratified, you're selecting a few from each. In Cluster, you're selecting all from a few. I don't know if that helps you at all, but you're taking all of the things in that group, but you're only selecting a few groups. All right, so back in the day when I first taught you this, I gave you this idea of a garden. Let's say that we're going to talk stratified. With stratifying, you want to group based on similar features. So I would group all of the carrots together. I would group all of the green beans. I would group all of the tomatoes, and I would group all the lettuce. So I would have 4 different groups. Okay, and then I would select like maybe 2 from each group. So let's say that I have these numbered 1, 2, 3, 4, 5. And I put carrots into a hat. Numbers 1 through 5 are in that hat. And maybe I'm going to draw out 2 things. Let's say I happen to draw out number 3 and number 5. Those would be the 2 carrots I would use. And then I would do the same thing with beans. And I would draw out 2 beans. And maybe I draw out the first and the second. And then I do the same thing with tomato. And I draw out 2 tomatoes. So maybe I draw out the second tomato and the 4th tomato. And then I do the same thing with the lettuce. I draw out 2 pieces or 2 lettuce. So maybe it's the 5th and the 3rd. All right. So that's stratifying. My groups are based on similar features. If I cluster, then I want to have many populations. So I want a mixture of everything in each group. So I would actually then group horizontally. That way I would have a carrot, beans, tomatoes, and lettuce in each group. And then I would say, okay, this is group number 1, group number 2, group number 3, group number 4, group number 5. And I would put all of those into a hat. And then maybe I would draw out 2 numbers. And let's say that those 2 numbers were, let's say they were like a 3 and a 5. Okay, well then that means I'm going to take everything in group 3 and everything in group 5. Okay, so do you see kind of the difference between stratifying and cluster? That's going to take a little bit of time to remember. And then we had multi-stage samples. I kind of doubt this is going to come up, but this is the general idea is just taking something really big, like a nationwide survey, and like paring it down. So you start with counties, and then within those selected, you go down to townships, then you go down to blocks, then you go down to households. Systematic does usually come up on the AP test. They like to throw curveballs at you and make you think it's systematic when it's not. First of all, you have to have an ordered list. So maybe you order people by height, let's say. Or maybe you order people by age. But it has to have some sort of order to it. And then what you're going to do is you're going to skip count. That's where it says then select every kth item. So that's skip counting. But you have to have a random starting point. Don't always start with the first person. So when we did this in class, I think you guys ordered yourselves by height, if I remember right. And I can't remember how many I selected, but let's say that I wanted to select 5 people. I think what we did was, like, let's say there were 30 people in the room and I want to select 5 people. I would divide by 5. So that would mean that I would skip count by 6s. And that means that even if I start with the 6th person and then I skip count by 6s, I will still be able to get 5 people out of those 30. Now, whatever this number is right here, this is what you're going to skip count by. And then you have to randomize the starting point. So you have to randomize 1 through 6 as your starting point. So let's just say that I start with the 3rd person. Then I'm going to skip count 1, 2, 3, 4, 5, 6. So that'll be the next person, and so on, until I get 5 people. So this number down here, this is the number of people you want. Okay, so that's systematic. Just because people are lined up doesn't make it systematic. It has to be ordered. If they're not in order, then the whole point of it's not going to work, because you want to have everything spread evenly throughout the population. So like if this was by age, I would get some young people, some people in the middle, and some old people. It would be kind of spread out. All right, I think that's hopefully okay with systematic. And then this is just the different kinds of bias. Under coverage, that would be like, well, we just had the census just this couple months ago. I filled it out online. So under coverage, that'd be homeless people. They're not being represented because the census is talking about households. Non-response, that is when someone is chosen to be a sample person in the sample, like maybe you randomly select households in your neighborhood. So that house is chosen, but for whatever reason, the people choose not to respond. That would be non-response. Then you have response bias. That is when people do respond, but their behavior could cause the bias. So maybe they lie on the survey or something like that. It could be intentional or it could be unintentional. And then question wording, if it's too complex, if it's too wordy or too preachy, or the order of the questions is leading or something like that, that can cause bias. So those are just some things that might come up. I think that's it. Yep, that's it for today. And then we'll talk more about experiments the next time. All right, have a good day.